we have the file example BC with exit 5. Now I will expect, yes, RDI to have 5. And the coolest thing of all, if we run the example out and see the exit code, oh, come on, it's 5. Holy. Hello everyone, today we're making a compiler, a better C compiler. C is a very powerful language that have lived for a long time, and because of its simplicity. But there are some quirks and problems with it. Since it was made like almost 50 years ago, people didn't know what you would want from a compiler. Now we know more, and I want to improve C. I don't want to go too far from it. I want to make a language that is better than C, that fixes all of the issues with it, adds some very nice features, but overall is like C, like the idea is the same. And by the way, cheers, by the way. Tasty. So, as you can see, the compiler is going to be called Better C. So the BC extension. Well, okay. A lot of people think that the compiler is like the complicated black box which is unwieldy, but actually all the compiler does is translate text, well, your code, which is just text that you can read, into the executable, which is a binary code that CPU can read. That's it. So like you learn a new language, like French or whatever, and you translate from English to French. This is the same exact process. Compiler just takes one stream of bytes and translates it into another stream of bytes. Okay, well, how do we write executable? How do we write binary code? Well, it's literally zeros and ones, which is really not readable, really hard to remember. So we have assembly, which is just textual labels for the zeros and ones, literally. So the assembly looks like something like that, you know, just some instructions, and they are translated into pure zeros and ones, which are executed. Okay, all right, well, what's the simplest program possible? Well, the simplest program is the program that when you run it, it immediately exits. So, well, for example, exit.out. You run it and it stops. That's the simplest thing. So we're targeting Linux, x86 64 assembly, and we're using FASM. So, well, sure, here you define that we're targeting ELF, which is a Linux executable file format. Here we start the code. We say that the code is the segment which is readable and executable, and the start is the start label that Linux jumps. All right, how do we exit the program? Well, we can just, the program is not a function. You can't just say, hey, let's return. It doesn't work like that. You need to call the exit syscall. So the C example, the C, what do you say? So this program is essentially the same as example. Now, int main return 69. So how do we emulate this kind of program in assembly, or how do you write this program in assembly. So, okay, what is 69 here? Well, actually, it's more like exit 69, and exit is a system call. So it's a function that the operating system implements, and you can call specifically this function from user code. So that's why syscall. that is the syscall. So all right, how do we do syscall exit? Well, first of all, we need to know what is the number of the syscall. So we can look into the syscall table. If we look for the syscall exit, by the way, probably should do something along like that. So the exit system call has the number 60, and the only argument is integer. Well, I got it here, so you can see it here. So the exit system call number 60, and the argument is errcode. All right, how do we provide the arguments to the system call? We provide the arguments via registers, which are kind of like just numbers, literally integer numbers. So we assign 60 to rax, which is the way to indicate that we want an exit system call. Now we assign the first argument, RDI, the error code 69. So rax equals 60, RDI equals 69. And now we do the system call, which literally just takes those registers as arguments and executes something. All right, let's try to compile it and run it. Well, actually, assemble it. Let's assemble it. So exit.asm and exit.out. All right. Well, I've shown how this program works before. It just exits, which is absolutely fine. Now let's check the return code 69, exactly what we specified. We can change it here if you want, something like 42, and if we reassemble, run it again, we'll see that, hey, here we go, the 42 is here. Okay, very, very cool. Let's make a compiler that will that will print the simplest program. So we can take any file and translate it into the simplest program. So we don't know anything about the program, but we already produce an executable. All right, let's do that. Okay, so that's all right. So I've prepared some files here which will make our life easier. We're going to be writing in C, though there are plans for self-hosting, so writing the compiler in the language itself. But it's for later. All right. So, well, the first thing you do in any C program is you write a hello world. So let's go. Include stdio.h. Oh, wow. Oh, whoa. My bad. And now, well, let's go include this stdlib. It doesn't hurt. Now, int main. Let's go do the return 0. Why not? I don't think it matters here. And printf. Hello world. Hello. All right, that's good. So let's try to compile it. Clang source what main there. All right, we've compiled. Now let's run it. Main it out. Hey, we got the hello world. Nice. C speedrun. Absolutely. Yeah, and as expected, we got the 0 exit code. All right, what's the next? Well, let's read any compiler. How do you specify? So here I typed Clang, then source code, then output. How do we do that for our program? Because like if I provide something here, well, it doesn't care. So how do we read in those arguments from the command line? Well, we use argc and argv. Yeah. So argc and argv. I like to handle those arguments, well, those things with a simple macro. And now let's include my macros. The macro is just shift. It basically pops the argument, and that reduces the count of them. So argv, argc. So let's illustrate how it works. It will return a string. So arg, for example. So let's print this argument. Yeah, arg, yes. I guess we don't need that. So arg. All right, let's see. Let's see what it will say. All right, let's recompile and run it again. Okay, the first argument is the path to the executable actually. All right. Well, if we get the next two arguments, well, we'll see the other things we provided. So, but you must be wary. What if you provide less arguments than than we ask for? So what if we? Well, sure. Right now I can compile this one. I can compile this one, run it, and hey, we got the 3 arguments. But what if there are less, right? Well, the macro will return null if there are less, so you got the null, which is fine. But okay, I want to provide 3 arguments basically. I wanna make it something like that. So we have our program or our compiler, then our input file. So example like .bc, and the output. So example like .out. So I wanted the compiler to kind of read in the input and give the output, produce the output as an executable. Okay. So well, basically the first argument is always guaranteed to be present. So otherwise you couldn't even call the program. So the first argument is the path to the program. So let's just say, but all right, so I also have to introduce the string library, since C strings aren't the most simple to use, and I have my own library. So implement. All right, so let's wrap the C strings into my own. So stir view. Yes. So well, basically this is program name. Okay. And now let's check whether there are any arguments left. So the first argument is kind of given, but the others not necessary. So if argc is less than 2, so I want to have 2 additional arguments. So the input and the output. So if it's less than 2, let's report an error. Say something like fprint f something like std error, and so here I would want to print the usage. So let's have a separate, no, not necessarily. So okay, so here's the usage. Usage is, well, yeah, here let's put the so print string. Then okay, so then we want to see the input dot bc. Then I want to see the output dot out. Okay, and new line. So fmt, it's fmt string, and well, roll basically. And of course, let's return. I don't think it's like an error, so let's return 0. Like it doesn't. It's okay. Basically, it's okay. All right. So what do we need to do? All right. Let's actually let's see whether it works. All right. Okay. Now I need to fix an error, which is a little bit inconvenient, and also another error. Okay. Oh, hey. All right. Yeah. Fair enough. So the type is not C string, but R string. Str. All right, that should be good. Sister view. Well, std aim, or not std, but st string. Fair enough. Yeah, that's all right. Okay, so we provided 2 arguments. It's fine. We provided less arguments, and we have the usage printed. Pretty good, pretty good. All right, now what? Now I need to basically, I think I can just ignore the input file for now and just use the output. So okay, so input and output. Here we go. Okay, so I think I want to write assembly into a file. So output.asm, and then I want to give that output asm to FASM and get the actual output. So let's create asm path. I don't know. So str add. Whoa. Str add. So it's going to be output and string of .asm. Yeah. Okay. Now let's open this file. So let's open the asm file and write something to it. Okay, so let's go file, asm file, fopen. Okay, and here we go, the asm underscore path data, and let's open it in writable mode. Okay, now let's write something to it. Fprintf asm file. Okay, so what do we want to write to the file? Well, we want to write our minimal, our smallest program possible. So let's just copy it, and then, I mean, let's copy and then clean it up. You know, main. Oh no, come on, loading too slow. Okay, so no, yes. Okay, so let's clean it up a bit. It doesn't need to have all those things. Yeah, that's good. That's pretty good. So, unfortunately, C doesn't have multi-line strings, and we're gonna fix it. Okay, so, well, what do I do? I guess I do this. That's fine. Now, let's go to the end and do something like new line and end of string. Yeah, that's pretty good. That's pretty cool. Okay. All right. That's kind of it. We printf this thing into the file, and then we close the file, I think. And actually, we need to check whether the file successfully opened, I think. Not sure. Let's not check it for now. I don't think it matters right now. All right, so fclose, awesome file. Okay, cool. So now let's call the FASM. So it will take the assembly and turn it into the actual zeros and ones, the binary code instructions. All right, so we're gonna use this system function, which will basically execute something in the shell. Okay, so we need to make a command. So command, well, it's gonna be something string add. So stir FASM. Then we have the ASM path. Then we have, well, I guess we need to have some separation, and now the actual output, the actual binary code. Okay, well, actually, let's print it, so it would be nice. Printf, basic logging. So you can see, you as a user can see what's happening there. What your compiler is doing. Okay, so print stir. Well, let's add new line and format string. Yeah, so format string, format string command. Yeah, we want to print command and then actually run it. All right, that's pretty good. So the command, whatever command prints, we will see as well. So it doesn't hide anything. All right, that's pretty cool. That's pretty cool. I think that's it, right? So let's see whether that'll work. Okay. Calang make. Oh yeah, I also forgot. I keep forgetting. I think I need to change it because it's really not what I think should be happening, right? Okay, so command. Oh yeah, fair enough. So command dot data. So because command does not take our custom string, it takes C string. All right, finally. Now let's run this. So, I mean, it doesn't matter what's in the BC, not the BS. But so let's just make sure that there are no example out. So there's nothing. I mean, I've ran some things here. Let's remove example. Oh, come on. Example out dot asm. Okay. So, all right, let's try it out. Okay, we should see. All right. So, FASM executed successfully, and now we got the example out and example out asm. So we can look into the example out asm, which will most likely not be anything new. It's the same thing. And by the way, I mean, it's okay. Yeah. So we'll expect to see 42 as a return code. So example dot out. Yeah, it just exited. Fair enough. And we got the 42. Great. So this is like the minimal compiler that makes the minimal program, but it's not really fun. Like, okay, a program which just exits with the code you can even change. It's not fun. Okay, let's have an ability to change the exit code. So this the simplest thing. all we need to do is basically change this number. Okay, how do we do it? All right. So now we need to read our input, actually. Let's just read the file. Let's read the input and see what's up there. All right. So yeah, also let's open it, but for reading. All right. So open for a reading. And here I think we definitely should check whether the file, like if the file does not exist, then it probably will error out. So input. Input file. All right, so if input file is not, for example, null, I guess. Don't really remember what's the code, what is the error value, but probably null. Then we probably should print something like do something like this. Okay, so fprint now could not open the string file, or could not open input file, and here we go, the string. All right, that's good, that's pretty good, but here it's not the prog, it's the input. Good. All right, and let's just read it as a whole. So, oh, maybe I need the read line or something. Oh yeah, okay, so unfortunately C does not have a function read the whole file, but it's a very, very useful function to have. So maybe let's write it or something, or maybe Google it. Let's see. Should it's such a... Right, let's just Google it, whatever, right? So, C, read, yeah, I mean, whole file. Okay, let's go. Read entire file, yeah. Well, we need to know the size of the file and then create the buffer of that size, which is, I guess, the intended solution. Sure, whatever, right? Malloc. So yeah, here you got the file size, and here you read the file. All right, sure. Let's just create a separate function, shall we? I think that's the way. So string read entire file. All right, and it'll accept string string path, probably some file path. Okay. So let's just go. Let's go copy the whole thing. Shouldn't. Why not? Should be fine. All right. So, all right, that's the file. And we got the file path dot data, read bytes. Yeah, sure, let's read bytes. Wow. though, I mean, yeah. Okay, so, okay, now let's just relay the let's doesn't matter. So okay, we got the size, which let's do it. Let's make it U64 actually. So and also let's include the numbers. Number. Yeah, so okay, so U64, F size, whatever, string. Okay, so since we have the length of the file, we just allocate that amount. Here we got the C string actually. So sister, let's go sister. Sister, let's go Haley. Sister F size. Yeah, sure. Fair enough. And yeah. Sister. And we will return the our string. Which is sister and f size plus 1. Alright, that sounds about right. Okay, so read entire file. Great. Yeah. Okay. And yeah, by the way, of course we're leaking some memory here and like here, but it really doesn't matter right now since our compiler is not a program that runs for a long time. The system will clean up everything after the compiler either way. So okay, well, let's read the read entire file finally, right? It's like imp file, and we got the entire file. So which actually is the real input. So this is probably something like imp path or like imp path, right? So imp path, which is kind of cryptic, but path imp path. Oh, no way, I made such a mistake. Okay, that's good. Output can remain whatever, right? Though I guess we can also rename this to output path. So it will be symmetrical in a sense. So out path. Okay, let's hope it will compile, and let's just print whatever we read, right? So this is the actual input. All right, and let's just print it, whatever. So printf. Well, let's see. So the file input. Here we got the input, and it's pre-stir. And here we go. We add the new line. All right. Stir input dot data. Okay. Now let's see if it compiles, and we'll see what it looks like when we run it. So, read entire file. Well, file path. Sure. What's the big deal? Stir. Oh, whoa. Yeah, that's definitely not Correct. It's input path. Well, that's what I love in languages that have type checking at compile time. The errors, you know, you have just you're much more confident that the program will work, you know, and it's really important. It's really important. As much as I like Python and its simplicity, I think we can have the same simplicity in C, just with a just a bit better language, bit better standard library, and you know, they're trying to make Python faster, but it's kind of like they have chosen the wrong path and now they're trying to steer so hard, but they just can't get there. It's so unfortunate, but hopefully we'll fix it in at least in some way. All right. So yeah, I'm sorry. Yeah. Of course, it's not just input data; it's format. So FMT format string. Yeah. And of course, you need to put take the address of it. Hell yeah, we got we make it compile. All right. Well, let's. Could not open file example BC. Okay, well, do we have it actually? Example BC. Interesting. So let's just check that it definitely. What's about less example BC? All right, it's kind of empty. I don't know why it couldn't open it. Oh, by the way, I know why. So yeah. Oh yeah. Look. So I need to move this error handling into here. And now I need to return the error, or I can. I don't know. I mean, I can return like a invalid string. I don't know. Should I? It feels bad, but I guess it's fine. So could not open input file. Yeah. Could not open file. Just could not open file, right? Could not open file, and this is file path. Yeah. All right. And now we just need to check whether the if the input data is equals to null, then we just return like 1. So it's like an error state. Okay, let's see. No, not bad. Yeah. Well, surely. We need to just say if f is not null. Okay. Expected expression, yes, of course, because we need to say that this is a string, actually. All right. Now let's run the. Okay, so could not open file example BC. Still could not open the file, which is surprising, actually, since it exists. Weird. That's kind of weird. Well, why would it not be able to open it? So, I mean, maybe let's write something in it. So, I don't know. And I mean, okay, the spoil for the future is we're able to specify the exit code. Okay, so sure, we got it here. Still could not open file example BC. This is very, very surprising. Very. Let's listen for the T. Whatever. It's probably an incorrect handling. So yeah, if it's actually equal to null, then we say the error happened. All right. Okay, finally, we read the input file and we read exactly what was written there. All right, that's pretty cool. Okay, and it compiled the same thing. So okay, now we kind of need to extract that 5. So we need to extract that 5 from the whole text. So we need to ensure that first goes exit, then opening bracket, then some number, and then 5. All right. So how do you do that? Well, this is called parsing generally, but okay, so not just parsing, but also, so lexing is breaking into tokens. So exit is a name token identifier. This is open parenthesis, right? Which is also a different token. This is 5 number, different token, closing parenthesis, another token. All right, so the first thing, I mean, we really don't have to tokenize it yet, because we can just literally check if the line starts with exit opening bracket and ends with this, and in the middle there's 5. So let's do the simplest thing that gets us to our goal. Let's not overcomplicate this. There's no need for that. All right. By the way, I would really like to also, have a function write entire file. I mean, sure, there's not that much code in there, but it just it would make my it would make me really happy, I would say. So just a little nicer. So okay, write entire file. So write file with a, I mean, write in entire file, right? So, all right. Oh yeah. Well, basically, what we need is something along those lines, and then yep. So file path and contents. All right, contents. Contents.data. Yeah. Well, actually, as in file, more like just print string. And here we go with fmt string. I don't know. Okay. Asm path. Well, it's not asm path, but file path data. So we open writing bytes. Let's go writing bytes. Okay. So asm file. Yeah, sure. I mean, we can also just say f. That's shorter. Definitely shorter. I mean, that's right. Cool. Cool. Let's use it now. So write entire file asm path, and here we got the string. It didn't change much, but hey, it's now kind of self-contained. All right, let's just check that it still compiles and okay, yeah, of course I need to do something like this, you know. And just final test, example.out. Yeah, it works. Great. Let's parse, let's get our number, our exit, our return code number. Okay, so let's make it like, I don't know, CU16. It could be, okay, so it's, let's go with integer, signed integer, I don't know, 64. No, I mean, it's, as far as I remember, it's like, well, it's not 16, 32, no. No, it, so, yeah, the main function returns integer. Integer is like at least 32 bits-ish, but the return code ignores higher bits. In the end, the maximum is like 255. Yeah, so it would be more like U8. Yeah. Okay, so U8 parse file. All right. Now we got the file. So, all right, parse input, right? Input. Parse the input. Okay, so what do we need to do? We need to go through each line. Let's do that. So, okay, so string strip. So string strip will accept input. It will accept input. I mean, actually, let's search string strip. Yeah, let's see. So returns a slice. Sure. It will accept self and chop till the character. All right, actually, let's make a function chop by line. I think it's a useful general purpose function, or maybe, I don't know, strip white space. Well, look, white space has to kind of ignore everything. You know what? Let's say that our exit have to be on the first line. Okay, so let's ignore everything else. All right, so let's check that starts with that the input starts with, actually interesting, I forgot already. I forgot everything. So str.h starts with takes two strings. Okay, fair enough. That's fair enough. Okay, so input, and here you go. String exit. Yeah. Okay. So if the input file starts with exit something, then we can say, no. So it's a prefix, right? It's a prefix. Str exit. Okay. So no. My bad. Prefix. So if the input file starts with prefix, oh man, I'm all over the place. Yeah, got a new keyboard, kind of not used to it actually. All right, so if it does, then cool, we can continue parsing. If it doesn't, though, it's an error. So the file has incorrect syntax or whatever. Let's say return Okay, so yeah, well, let's go return -1. It will be our error code. Okay, so or maybe no. You know what? No. Okay, so we can return. Let's go with I16. I16. Yeah. And it will actually be -1. All right, fair enough. Okay, well, I mean, we can print something like, hey. Oh, come on. So invalid or like error. Yeah, let's go with fprintf, shall we? Fprintf std error. Oh, I'm all over the place. Anyways, so error, invalid. Okay, so syntax error. Let's go with syntax error. Oh my, syntax error. This file does not start with with, or actually, you know what? Yeah, it does not start with pre-str. I mean, still, I need to have the quotes. Let's still have the quotes, and we add the prefix. Okay, fmt str. So prefix. All right. Okay, so we ensured that the first part has the exit in there. Okay, now we gotta parse the integer. Okay, I also have some special code. Well, again, C does not have any good standard solution with good error reporting. It's either error no or something else, which is really weird. So I just written my own implementation, which is actually not that hard. So string to int. And if I remember correctly, unfortunately, I didn't implement parsing of unsigned integers, and it's fine, actually, it's fine. I don't need to here. So str to int implement. Okay. And let's say the actual parsing is gonna take in only U8. So U8 value. Now we do something like if str to int, or more like str to U8. Well, what do you say? You give the, yeah, I mean, we'll see. I think it's kind of okay to pass strings here as values and not references. Whatever, I don't think it matters right now. But it's just simpler to pass it as a value. But anyway, so input and what else? The value, right? Of course, the value. The value. Oh. So, so if the parsing, how do we know that the parsing is wrong or has failed? Well, we go and say, so start to, okay, really? No way, man. Why do you not show anything? That's surprising. I did something wrong to it. Let's save and exit. That's it was showing preview, but anyway, so we just check whether this thing is okay. All right, let's go to main. All right, so if the string to int to U8 is not okay, then we just print something. Well, it's kind of the same pattern. So we print something here, saying like, hey, you got the wrong integer, syntax error. Exit expects to have you unsigned in 8-bit 8-bit integer. Expects, well, maybe not expects, takes, maybe takes, exit takes in unsigned 8-bit integer. Okay. Yeah. Yeah, well, we can get the error code there, but I don't think I care here that much. So it'll parse as much as it can. So we'll see, right? Okay, cool. Now we got the value. Now let's just ensure that we have the closing bracket. We don't really have to, but so there can be something like, so exit 5 something this. How do you, well, currently we will parse 55 here and leave the s, and maybe you meant something else, so we just gotta make sure that what you meant is actually what you will get. So we will only need to check whether by the way, I don't think I moved the input anywhere, and I think I had to actually input. Yeah, I think I need the advance function. But anyway, so input data, because I see it everywhere, this pattern, to advance the view, or like cut the first part, whatever. So data plus equals what? Prefix length and input length. Yeah, so we chopped this part. Now the string to U8 will chop the integer part, and now we only need to check if the input data what input data is essentially closing bracket. So if it's not, we say something like, hey man, not cool, you gotta close it with this. All right, let's see. So syntax error, exit, so bracket was not closed. So what kind of bracket is it? I forgot. Curl, it's not a curly, of course. I don't know. But anyway, so the bracket was not closed, right? The bracket was not closed. But let's keep it short. Bracket was not closed. All right, and also it would be nice to, it would be nice to point to exact location where the error occurred, but for now, let's not worry about it. Let's just make sure it works at least in some way. All right, so let's see. So return value. It's actually, when we parsed it correctly, we will get the positive value, which is actually U8 under the hood. But yeah. Okay, that should be good. Let's just see. Let's just try to parse the file and then add it here. Okay, so instead of, printing it, let's parse input. Input, and we will get the exit code, or yeah, so inside of an application it's exit code, and outside it's return code. Well, anyway, so exit code, which is I16 actually. All right. And now if exit code is less than 0, it actually means we got the error. So how do we handle it? Well, essentially we return with 1. We say no, thank you. And actually let's put this inside the curly braces as well. Or maybe not need to do that. We'll see whether. All right, good. Now we need to insert it here. So, okay, my intuition was wrong. Write entire file. I mean, maybe it wasn't so all that wrong. It's just that we need to make it like a macro or something. Define, write entire file, file path, contents, and 3. But yeah, that's no. It doesn't work like that, unfortunately. Okay, so let's not have it. I think it was the wrong idea. Okay, I'll fix that later. Let's just put it here. Yeah. It's like almost. So asm path, contents. Yeah. So here we'll have something along the lines of D. I mean, let's just go with pre U8, I guess. Okay. Yeah, okay, we'll see. Stir contents, or maybe it's actually the output. This is the actual output, indeed. Okay, so output. All right. And we need to provide the arguments. So yeah, actually, instead of having it as the format string, having it as an argument to the format string, we will have it, the output, as a format string. Okay, so data, and what do we say? It's exit code, and we cast it to U8. Okay. All right. Sounds about right. Well, let's go asm file, asm file, asm file. Yeah, so I guess I do need to have some. I mean, maybe my intuition wasn't wrong, but I need to have string builder, which I don't have right now handy. But yeah, let's go with that. Okay, let's see. Let's try to do something. Let's try to compile it first. Okay, okay, 35, right? 35 length. Oh no. Okay, let's see now. What? Okay, and probably something like, yeah. So Yeah, it definitely is the wrong default, because I keep stabbing myself, keep stabbing my toe with this thing. All right. I don't know. Let's see. Okay, so predicts. Yeah, predicts prefix actually. Yeah. Okay. Okay. Nothing else. Okay, prefix. Okay, so we need to actually start. Okay. Oh. Okay. Sure. All right. Now it compiles and. All right. So it should have. Okay. Again, we have the file example BC with exit 5. Now I will expect, yes, RDI to have 5. And the coolest thing of all, if we run the example out and see the exit code, oh, come on. It's 5. Holy. All right. We got a basic compiler which can produce an executable that returns some error code. And let's test it. Let's test our error handling, our parsing. So what if there's nothing? Or like it's not the first line, since we said we want to have it on the first line, right? Our compiler says, hey, syntax error, file does not start with exit. Yes. All right, so what if we don't close this thing? Well, let's see. Yeah, the bracket was not closed, indeed. And now, well, what if there's nothing in there? No defaults, we don't have defaults. Exit takes in unsigned 8-bit integer. So there were no integer there, and yeah, exactly. So let's simulate our example, our bad example I showed. The bracket was not closed. So this is the shortcoming of the parsing algorithm. We don't see where exactly the error is happening. And that's kind of a problem. I think it's like, well, what's interesting about compilers is that their UI, their user interface, is literally the command line, the errors that they print. So to make a good compiler, it's necessary to have good error reporting. It's so important. And well, one of the reasons why people like Rust is it gives quite like verbose and explanatory errors, which is really good. And I think, well, everyone who have used C++ can probably attest to the awful errors that it produces. The Clang GCC and just generally CPP compilers produces. Like, it's a wall of ugly text. So keeping it tight, very terse but very information dense is what makes a good compiler. Well, of course, that's not the only thing, but it's an important part of it. Okay, well, look, we got a basic compiler. Let's do something like, okay, so let's get back. Let's just test it a little bit more. So like 55. Let's try that out. So no, it's yeah, 55. It's such a simple and cute compiler, and I think why not commit? Let's do a commit. I think we've done some good job here. Oh God, I can't print. I can't type. Let's commit or like, okay, so git diff status, git diff. Yeah, something happened to all of them. Oh, that's fun. Uh, oh, that's not nice. So okay, let's try to do something like git add source. No way, man. Shouldn't have happened. Oh, I don't know. Well, anyways, I'll finish it off camera. I'll fix those errors. And thank you for watching. Next time we'll add something more interesting. We'll expand the parsing. So right now parsing is quite dumb. We'll go into the lexing and making abstract syntax tree. So AST. That's gonna be fun. So thank you for watching.